In the 1400s, the printing press revolutionized the way we share information. In the 21st century, a new printing technology has emerged to help us transfer our ideas from sketches on paper into physical form at record speed. 3D printing. Behind these rapid prototyping capabilities is a scientific process of materials, mechanics, and software. As a student in Vanderbilt's digital fabrication program, I'd love to share with you what I've learned on this topic. Let's take a look under the hood at the science behind turning your wildest sketches into objects you can hold in your hand. One of the first steps in building anything is sketching it out. In the 3D printing world, sketching is done using computer-aided design software, called CAD for short. The first step in CAD modeling is sketching out the base of your object using 2D shapes and lines. The next step is assigning positions and dimensions to those shapes and lines. Finally, you can extend your 2D sketches into 3D, also known as extrusion. Giving a shape or line a position is just like plotting it on an XY coordinate plane. During printing, the printer bed mirrors that coordinate plane. Dimensioning your CAD model is a very important step to ensure that all your shapes fit together as intended and print at an appropriate size relative to the size of the printer and your needs for the object. Finally, extrusion in CAD is like grabbing your 2D sketch off the page and pulling it to give it height in the third dimension. Just like using a stencil when drawing a shape on paper, 3D printers use CAD models as their guidelines for where to place material on the printer bed. A 3D printer is really good at following instructions, but not much else. It needs to know exactly how big and at what position you want your shapes to be, or else it will not be able to print them. Imagine a Lego set with all the right shaped bricks, but of all different sizes, and with no instructions on how to arrange them. There would be no guarantee that these bricks would even fit with each other, nor any clear instructions for how to put them together. Now imagine a Lego set where all the bricks follow the same sizing standards. That's your positioned and dimensioned CAD model. The printer also interprets the CAD model like a Lego instruction booklet, using it to determine what gets printed where. So how does a CAD model become a physical object? Every 3D printer has some material source. The most common is plastic filament. Think of it like a big spool of thread, except the thread is made of plastic. The printer heats up the plastic filament until it's slightly melted and places it onto the bed, as if it's a tube of icing for a cake. Instead of your sketch simply jumping off the page as it does in a CAD model, the 3D printer divides your model into a bunch of thin layers. It then places material in the 2D shape of each layer onto the printer bed. The filament has some thickness, which turns those 2D shapes into 3D layers. Starting at the bottom and giving each layer enough time to cool down and harden before placing the next layer, the printer builds one layer on top of the next until completion. Think about making a fancy cake. You wouldn't start at the top and go down, and you wouldn't go left to right either. To make sure you're working with gravity and not against it, you would start by baking the bottom layer of the cake, and you continue adding on top of that. This is the same way 3D printers work. The great thing about 3D printing an object is that if it didn't come out how you wanted, it's very easy to go back into your CAD model, make some edits, and it's very inexpensive to print a new version. Plus, your failed prints can be ground back up and turned into new filament for the next user. I hope this video helps you to get a glimpse behind the gears and see that behind the futuristic tech of 3D printing lie many familiar concepts from your everyday life. Thank you for watching.